Hello everyone, I am Pushpendra Kumar Shukla, a PhD student at Indian Institute of Technology, Mandi. Today I will be talking about one very interesting topic of local heating system. So that topic is goes to effect of input parameters on energy requirement of a phase change material integrated local heating system. In this, I will briefly introduce what is local heating system and what is the need of that work. And after that, what experimental setup we made, I will briefly discuss about that experimental setup. And after that, what measurement we did. For more clarity and for more optimization of that existing design, we also did some simulation study using ANSYS Fluent commercial version 18.1, and then validation of the work preceded by results discussion, conclusions, and some references. So what is the local heating system? The local heating concept is one of the possibility by which we can save a substantial amount of energy. As we all know, the space heating in residential sector in winters accounts a considerable amount of conventional energy. So which this energy can be easily saved by implementing some means like this. So idea behind in the concept is we are reducing the area, and as we reducing the area of need to be heated, as a result the energy requirement also can be reduced, and it had been seen theoretically 50% amount of energy we can save by implementing this setup. So in this work, we had made one insulated dome over the bed along with copper coiling in different location with different configuration for finding the best possible solution from it. And this like floor coiling concept we got from electric blanket itself, and this these things will be discussed in detail in subsequent slides. Water was used as heat transport as it is expensively means available for us. So, so as I earlier told that if we compare the electricity consumption of our institute IIT Mandi itself, so we could see that there is around 50% more energy we are using in winters as compared to summer, and which is mostly because of space heating and these type of heating things. So and not only local, we could also see some energy users report of US residential sector in 2018. So they are using 27.3% energy uh, exclusively for space heating only. If we consider also for water heating, that time it will the figure will be more. So if we able to maintain this local heating kind of solution in at least in hostel area or somewhere where most of the time we are using like 8 to 10 hours we are using these type of appliances. So here we can reduce considerable amount of energy. So we for doing this study we constructed one experimental setup. So here we could see the experimental setup schematic diagram. So as I earlier said, initially we had planned it with solar water heater, ETC solar water heater, where we could easily able to achieve water temperature at around 70 degrees Celsius. But for more clarity and more variables, we had done some uh, lab experiments. For that, we had made we provided two tanks, one for charging, another for discharging. Charging tank has one heater. So during off hours or something means we used this heater for heating this water, and we took around 100-liter tanks. Why we took 100-liter tanks? Because so it reduce any kind of fluctuation in first few cycles, like For first few cycles, its temperature means decaying rapidly, but after for that only we had taken a large amount of water volume, so that these fluctuations can be avoided. So during charging, we could see that hot water is going through this thermal battery, which is spiral latent heat energy storage system, and after that it will pass through the uh, uh, dome over bed. So this we will see this in detail in next slide. So here we could see that from here water is coming here, and this is the latent heat thermal energy storage system, which is a spiral type, and after that its output, or maybe when source is not available, then we can use this energy for heating this particular setup. So in each section we had that confined area, which we will going to discuss in next slide in detail. So here we could see the inside view of that setup. So here mostly means we had done with three type of copper coiling. So for making it much better. So one is for with respect to floor coiling. Here we could see that this is these are the floor coiling which are means in the floor only, and after that we also did some experimental measurement with spiral coil at the top, and then we also did some measurement with zigzag coiling in the dome. This dome has been designed in such a way that it can easily be opened or closed in actual practice. So here for experimental purpose, we have not gone in that much sophisticated design, but it easily can be translated for with this as I explained with easier design for opening and closing. So so with respect to the previous means experimental setup, we had done some measurement. Here we could see that floor coiling is giving best result out of zigzag and spiral coiling. The reason behind that may be because of natural convection, heat energy coming from bottom to top naturally. So total temperature or average temperature maintained inside the dome was maintained something around 30 degrees Celsius, which is much better to spiral and other configuration. That time the atmospheric temperature was something around 7 to 8 degrees Celsius when this experimental setup has been the experiment has been done. For more clarity and finding the impact of inlet temperature, inlet heat transfer inlet temperature and mass flow rate, we had done some simulation study. For that, we made one model of experimental setup with one-third length for reducing the computational cost, and other things has been kept as with respect to experimental setup only. We had inlet temperature we maintained at 338 Kelvin, which is and with 0.5 kg per second, and we also did experiment with 338 and other temperatures also. I had not mentioned here. So uh, out of which we had means in, other boundary conditions with respect to inlet, outlet, dome, and copper coiling are mentioned here. So here the numerical study was validated with experimental results, and it was found that they are in good agreement with very less error. And this has been done with measuring the temperature at different locations. So at inlet of tube and outlet of tube, and also at different location, and these locations were matched along matched with for both studies, and it was found that they are in good agreement. So after validation, The results of numerical analysis has been presented here, which has been done in ANSYS Fluent 18.1 version. So here we could see most of the means dome is maintained at something around um, 20 25 to 30 25 to 27 degrees Celsius. The temperature near the walls are quite less, which is obvious because of less insulation maybe, or heat transfer from the insulation itself. So these are temperature contours on in front plane and perpendicular plane. Here we could see means how convection current is going on with respect to streamlines, and this figure is showing the local local temperature, how much it is fluctuating. So we could see that around 3 degrees Celsius temperature we could see is going to reduce in single cycles. So after that validations, these are the comparison of all three coils. So out of these three, floor coil is giving very good result, as it is attaining um, required temperature at very less height, and others for other configurations it is means variation is not means it is gaining after some time. So out of these three, floor coil is recommended for this type of design. Uh, for more details or optimizing the design, we had analyzed we had studied the effect of inlet temperature and inlet mass flow rate of heat transfer fluid. So here we could see that um, that higher temperature, as it is obvious, like higher temperature is giving very good result as compared to lower. And but in mass flow rate we could see that if that mass flow rate is beyond a certain limit, so temperature or energy means after some time is not that much significant. So for optimum design we could take any of this means upper range thing. So here one reason might be because of flow got turbulent in higher mass flow rate, and when flow is turbulent, then if effect of mass flow rate is not that much significant. So this is still a elementary study. More study need to be done for concluding in much so from these analysis we had concluded following things. So means it was found that bottom coil and zigzag coil will maintain the space temperature 15 to 20 degrees Celsius above to 2 atmosphere. And we already seen the effect of mass flow rate and inlet temperature uh, of heat transfer fluid, beyond which the limit in the condition as minimum, especially with mass flow rate. The mass flow rate after certain limit is not after certain limit, the change of mass flow rate is not giving that much energy change inside the dome. Inclusion of phase change material, thermal batteries give constant temperature supply with respect to charging and discharging, and also enable one possibility with where we can club this experimental setup with solar water heater, so we can make it totally off grid and very economical and sustainable solution for the space heating. As we could see that these suggestions can be game changer if we able to implement these things in much better way, so more study can be done in this field. So at the end, we acknowledge the financial support provided by Science and Engineering Research Board, Department of Science and Technology, Government of India, for giving this project. And I also acknowledge the infrastructure support provided by Indian Institute of Technology, Mandi, for doing this experiment. And these are some references with respect to our study. These are the contact details for any author for any kind of questions or doubt and suggestions. With that, I will thank you for your kind attention, and I welcome for your any questions and suggestions. Thank you so much.